Hello, everybody. My name is Susan Koudelakis, and I'm Senior Marketing Manager here at Progress. Welcome to our Ask Me Anything role-based access control webinar. So let's jump in by quickly introducing you to today's speakers, Todd Wright and Dennis Bennett. Todd leads global product marketing for Progress Data Direct Solutions. He works closely with the product management and sales organizations to create and promote materials that are relevant and valuable to Progress customers. He is instrumental in developing customer relationships and creating strategic marketing plans that drive awareness, consideration, education, and demand for Progress. Dennis Bennett has over 20 years of experience in working with companies to help solve their data connectivity challenges. In the past, he's worked as an application developer, DBA, and QA engineer. At Progress, he is principal sales engineer for the data connectivity and integration products. I'm really excited to have both Todd and Dennis with us today, and now I'll turn it over to them to start the presentation.
Thank you, Susan, and hello to everyone on the webcast today. On this webcast, we're going to be discussing in detail the approach and methods Data Direct uses to keep organizations data safe and secure during the process of connecting to various data sources, as well as working with various BI and analytics solutions. I thought it would be good to maybe take a step back and talk about some of the big security issues orgs face today. And probably no surprise to anyone when you see this list, it's some of the usual suspects. With the first one, data breaches, as we all know, occur when unauthorized persons gain access to sensitive or confidential data. And this is really due to poor security measures, such as weak passwords or unsecured networks, or through targeted attacks by hackers. And as much as organizations are, trying to temper down on data breaches, it's still something that we're hearing about on a weekly basis, and organizations obviously are trying to decrease. The second one, malware and viruses. They occur and can affect computer systems and compromise data security. Really, they're used to steal sensitive information and track user activity or gain unauthorized access to networks. And the third one, I don't think really gets enough publicity or really gets talked about enough, because it really does occur a lot within the 5 listed here, and that's insider threats. And these really occur when employees or other trusted individuals within an organization misuse their access to sensitive data. And this really includes stealing information, copying data for personal use, or accidentally exposing data through careless actions. In fact, the GDPR takes the insider threats so seriously that a lot of their provisions are actually geared towards the actual insider threats. The fourth one is phishing attacks, something that I need to be mindful, and I think everyone else needs to be mindful of on a daily basis. And these are the type of social engineering attacks that use fake emails or websites to trick users, really to providing sensitive information that they might be holding, such as login credentials or credit card numbers. And these attacks can be really difficult to detect and can lead to significant data breaches. In fact, some organizations really don't even know until after several days that this type of breach has occurred at their organizations through the phishing attacks. And the last one is data loss that occurs due to hardware failure, software errors, or of course human error. And this really can result in the loss of critical data, including customer information, financial records, and intellectual property. And it's important for organizations such as all of ours to have a backup recovery plans in place to prevent this data loss. So with all those concerns, the last thing your organization needs is yet another concern to pile onto the security vulnerabilities. And really, with that said, what my colleague Dennis will be going over today is our Data Direct Open Access SDK solution for data connectivity and its unique approach to handling your security. But before we do, you might be asking at this point, what exactly is Open Access SDK from Data Direct? Well, first, it allows orgs to build standards-based connectivity, whether it be ODBC, JDBC, and others, for underlying data that is compatible with the most popular analytic and data integration tools. And if your needs are unique and there isn't, for lack of a better term, out-of-the-box connector solution, Open Access allows users and orgs to easily develop their own solution for this. And second, for existing native connectors and those not built by Data Direct that orgs may already have, Open Access SDK provides the capability of those non-data direct connectors to be tailored to perform such operations as altering content, scanning queries, and or augmenting data. And this is really all without any extensive amount of code changes. And third, and which Dennis will discuss more, is the open access approach to security. This includes the ability to ensure privacy and security compliance by providing third-party encrypting and decrypting, row and level column security, as well as role-based access. So Dennis, I know I said a few things here, but with all of that said, I'm going to turn it over to you to go deeper into the topics for our audience, and I'll be back with you for the Q&A portion of this webinar. So Dennis, it's all yours.
Okay, thanks, Todd. So I'll start with talking a little bit about open access, and then I will kind of demonstrate what we've done with this. So for those of you maybe not as familiar with open access, it is our software developers kit for building drivers, but it also can be used to kind of augment the capabilities of existing drivers, and that's kind of what I'm going to be talking about today. Over the years, we've seen very, very different use cases with open access. We kind of joke that if there's 100 open access customers, there's 99 different use cases, and that's not too far from the truth. We definitely see people doing things like building connectivity to proprietary data sources that may not support SQL. We've seen people do things like building archival solutions where the end users don't need to be aware of where the data actually resides, and open access will kind of figure that out and return the data kind of transparently to the users. But what I've been seeing lately, and this is probably over the last 18 months, 2 years, seeing companies using open access for kind of augmenting security of an existing driver. And that's both sometimes financial services companies and also independent software vendors. And they're using open access with existing drivers, typically relational database drivers, and using open access to add to the security capabilities of that driver. And I'm going to be talking about role-based access control, where users are kind of given a role and based on that have certain data entitlements as far as what they can see and can't see. But one of the benefits of using open access in front of the database for this particular use case is you don't have to expose the database directly to end users. They can go through open access, and just kind of puts another layer in between. And then even more specifically, what we're seeing people doing is they're taking basically starting with sample code that we provide, and I'll kind of show you what I've done with it, and using it with an ODBC or JDBC driver. But they will they'll first intercept the incoming SQL statements entered by the users, and then inspect it, and then look up, for example, the role of the user and the data they're entitled to see, and then potentially modifying the result set. So there may be certain columns on a table that are private or sensitive information that the particular user should not have access to. And this is a way to go ahead and mask that or encrypt it. And the other thing we see people doing is implementing row-level security with open access with this particular use case. By that I mean they will add a filter to the SQL statement to further limit the data that the user is able to see. For example, you might have a user that is only entitled to see data in the US as opposed to global data. And by intercepting the SQL and adding a filter to it, that can be done through open access. And this can be done basically by taking some of the samples and adding a little bit of code to enable this kind of processing that I'm talking about. And we've definitely seen some of our end users doing this with open access. And so just at a high level, what is role-based access control? This is a way to, rather than having specific entitlements directly assigned to a user, we'll kind of create a role where that user, and based on that role, they have certain data that they're entitled to see, data that should be hidden from them. And in this example, or in this demo that I'm going to do, I've got a couple different roles set up, and I've got a couple different users. And based on the role, you'll see that they see different information, whether that's row level security, adding a filter to the SQL statement, to the select, or modifying the result set to kind of mask some of the data that's coming back to them. So really, each user has a role, and each role has certain capabilities and entitlements based on that. So Open Access is a good tool for doing this. And just kind of at a high level, what Open Access is, I mentioned it's a software developer kit. We put as much as possible into the product, and by that I mean everything that is standard in a particular driver that every driver would need is in the box. So things like network connectivity via ODBC or JDBC, that is all there. We have a SQL engine that can be used. My particular example is leveraging that SQL engine, but we also have modes of processing where that's bypassed, and all the SQL engine processing can be done by the data source itself. The stuff we can't put in there is the stuff that is specific to your particular use case. We sometimes call this the last mile code or the glue code. The name in the documentation is interface provider or IP code, and this is something that the user of Open Access would add their code in here to do the things to connect to their particular data source. And this interface provider code can be written in C, C++, Java, or .NET languages. I've actually used Java for this one. The nice thing about it is the language you write the custom code, the interface provider code, doesn't reflect back to the protocol you connect with. So example, I can write Java code and connect with ODBC, or I could write C++ and connect with JDBC. So you just really have to write it once and keep on using it. I mentioned that it does have SQL support with the SQL engine in there. This particular sample I'm doing is really just doing role-based access control for select statements, but it has capabilities to do more, and you can see. And different groups of users do different kinds of processing with Open Access. So there's flexibility, and we definitely see people doing this kind of in an iterative fashion, where maybe they'll start with a smaller subset of functionality and add to it over time, and that definitely is not a bad way to go either. As far as what the architecture looks like itself, this is what I will be demonstrating. I've got a client-server architecture, so there's an Open Access server that I'm going to connect to. Actually, for my demonstration, I'll connect with our ODBC driver, connect to the Open Access server. I am going to use the SQL engine that comes with Open Access, and I'm going to leverage an existing JDBC driver. In this case, it's actually Oracle. And what I'm going to do is modify the result set coming back, and also go ahead and potentially modify add a filter to the incoming SQL. So this is kind of showing, this is the JDBC driver that already exists. This dark green is my custom code, and everything in kind of the tan is the Open Access product itself. There is another mode of processing, which is called local architecture. And in that case, it is a single tier. The limitation is that it's ODBC only, but sometimes that's important to people. So I could, the sample I've put together would work. I could drop my custom code into this particular local architecture, and it would work the same. And the last thing I'm going to show is we have another product called Hybrid Data Pipeline, and we've done a fair amount of kind of webinars on that. Ask Me Anythings. You can kind of refer to those. But sometimes we've seen people who want to use Hybrid Data Pipeline and maybe, for example, OData, REST enable a data source. In this case, I've got that Oracle data source I mentioned, but I don't have a way to OData enable it But if I put it within Hyperdata Pipeline and use the open access driver, I'm actually able to get to my Oracle database and also put that role-based access control kind of functionality into it. So I just kind of wanted to show that. As far as how it works, that interface provider code, that custom code, there are different methods in there where you'll get control at different points in the processing. So in my case, I'm going to do special processing on the connect where I want to look up my user and establish a role for them and see at that point, what the entitlements are based on the role. And then when the SQL comes in, it will come in through an execute method. And at this point, I can do things like when I've actually passed the SQL statement down to the database, I'm able to go through the result set and, in this case, mask or just hide some of the data that maybe the user's not entitled to. And really, those are the two places, those are the two methods that I did my processing for this demonstration. There are a bunch of other things you can do, and I've mentioned, other people do a lot more with the product, but I just wanted to put together a sample just to kind of show this. So I started with an existing sample we have, and we can provide a link for that. This sample I've done is select only, and it's not supporting stored procedures. This is not something to kind of show you where you can just drop it in production. Really, what I wanted to show is where in the processing you might want to intercept the SQL, intercept the result set, and go ahead and kind of put your kind of augmented security in place. So definitely don't just drop this in production. Use this as a starting point. Just to kind of see where you might put your specific logic that is unique to your application. And there are other samples I could have used. I chose Java because I'm most comfortable, but we definitely have C++ samples. And I said I'm actually using our SQL engine, but in some cases it might make more sense to use third-party SQL engine mode where we bypass our processor, our SQL engine, and people definitely do that. It's just I picked one to start with, and I wanted to use parse SQL so I could reference the SQL that in the parse tree. So as far as the flow, as I mentioned, I'm using an existing JDBC driver for Oracle. When people connect, in my connect method, in the custom code, in the IP code, I'm going to look up the user who is logging in, and I'm going to determine what their access role is. And I do a lookup against the REST service that I have just running on a test server. It's a very simple example. I've just got two access roles, kind of low access and high access. And then based on that, I want to do another REST lookup to see, based on the role, what should be done to the result set data, the columns coming back. So for a low access, if I've got some personally identifiable information, I might want to mask it. So for example, if somebody's employee's name is Candle, I might mask it where you just see a little bit of the data and the rest is just been covered with asterisk. And I have another sample, something format preserving encryption, where manager becomes just some random string of characters, but it remains in the same format. So integers would stay that way, characters would remain characters. So that is one thing I can do. The other thing, there may be, in that case, the data on the database is actually in clear text. So if you wanted to do this, you would need to make sure that people have to go through open access in order to apply these rules. But we've definitely seen other cases where the data is sensitive enough where even on the database, the data is encrypted, and not something like a transparent data encryption through the database itself. This would be something where even the DBAs can't see this in clear text. So I also put something like that in place where if something is encrypted on the database, only somebody with a high level access role would see the decrypted data. So if somebody is entitled to see it, it would be decrypted. The city would show up this way. But for everyone else, and actually on the database itself, you know, it's been encrypted where they can't see it. The result sets are actually modifications to the result sets are fairly straightforward. In the processing, you see the table you're working against, you see the column that you are putting back into the result set, and at that point you can decide let it go unchanged or, you know, employ some sort of masking for it. The other thing I thought of doing, and this was a little more difficult, is to enable row level security. So in this case, what I would do is if a user is only entitled to see, for example, on the employee table, a certain department or a range of departments, what I want to do is add an extra filter to the SQL statement that they've entered to further limit the data coming back. So in this case, I'm putting a greater than filter on the employee table, and on the department table, I'm saying, you know, this low access user can only see department name equals accounting. And there's different ways to make this work. In my case, what I chose to do is substitute the table name itself with a sub-select. So you can see if something like this was entered from, you know, give me these columns from progress department, I'm going to look at this rule and see that department needs to be further filtered by putting a DNAME of accounting. So what happens then is I have a sub-select in place of the actual original table name. But there's certainly other ways to do it. And, you know, you would go whichever way suited your purpose and seemed most obvious to you. But really, that is what I wanted to show you as far as kind of a setup. And at this point, I'd like to demonstrate for you kind of what that would look like. So in this case, I'm going to show you, first of all, I mentioned that we have, I do some REST service lookups to see based on the user what their role is. So I've got one out here, a REST service that user Dennis is a high access role, user progress is low. And then beyond that, I want to see, okay, based on high and low, what should I then do? So I have another lookup, which in this case looks like this. So in this case, a low access role, when processing against the table department, I'm going to mask the location column, I'm going to mask the employee name, and I'm going to use format preserving encryption on the job name. If somebody is a high level of access, I'm going to actually, I'm calling it encrypt, it'd probably be better if I said decrypt. These fields are encrypted on the database itself, but since this person has the authority to see it, I'm going to decrypt city, address, one, and state or province. So that is what to do with columns, basically processing the result set based on the role. And then I've got one more in place, which is, this is that row level security. So a low level access person, I'm going to add some additional filters to their data. So if they want to go to the employee table and they say, give me everything, I'm actually going to say everything where department number is greater than 10. Or if they try to look at everything on the department page table, I'm going to just limit them to that specific department name of accounting. And I'm not going to do anything for the high level user. So that's my setup for the roles. Then if we come over here, this is my open access management console. So I've actually got this guy running on a server on a port that I'm going to create an ODBC data source to connect to. So let's see. I've got one called RBAC Pass JDBC. The open access server is on the same box as this particular open access server, and the ODBC client are actually on the same box. There's that port we saw, and there's my data source. So at this point, what I would do is just kind of show you within a SQL test tool how things will look differently depending on, you know, who you are. So I've got one here where I've connected as a low-level user, in this case, Progress. And if I do something like look at Progress customer addresses, I'm going to see the data. These are those encrypted database fields, and they remain encrypted because I don't have the access to see them. But if I connect with somebody with a higher level, in this case, the user Dennis, and I come in here and do the same SQL statement, we can see that the city and so forth, state and province and zip code, they all come back decrypted. And just to kind of show you, I also have a connection directly to the database itself, just to kind of show you that the data actually is encrypted on the database. You can see, so that's actually how it exists. And then just a couple of other ones. You know, I mentioned Progress Department. In this case, with a low-level user, we are going to do a couple things against Progress Department. First of all, we're going to limit it to department number of 10, and we're going to mask the location field. If I do the same SQL statement with a higher level user, we'll see, first of all, it's not limited to that one department, and also the location is not masked. A couple other ones I can show you. If I wanted to try to override it and say, well, I want to see 20, it's not going to let me do it because I've already got that filter that says it's got to be equal to 10. And then just another one I want to show you based on the rules. This is a low-level access person. If they come into the employee table, we are going to mask the employee name, so you can see with these kind of asterisks. And the other thing we would do is just do format preserving encryption on the job. So it's the same kind of format. It's text, or numeric, or whatever, but the data has been kind of obfuscated, so it's not really kind of helpful for that. And you can see there's 14 rows that are returned here, and if we do the same thing with a you know, higher level user, what we'll see is, you know, we'll see all of the rows. We're not just limited to departments greater than 10, and we can see the job and the employee name unmasked. So that's kind of what it looks like. The only other thing I wanted to show you is if I wanted to go in through Hybrid Data Pipeline, I actually did that. And let me just kind of log into that. So I'm going to log in. No, not you. And I've got a data source set up. This guy here, where I'm using the Open Access driver as a part of the Hybrid Data Pipeline server. And the other thing I did was I set it up with OData. So if I want to, I can actually go with OData, and I need to log in here with my Hybrid Data Pipeline credentials. So another benefit of this is I can even hide database credentials from the end user if that's what I want to do. But we can see the different tables, and for example, if I wanted to look at customer addresses via OData, you can see that I'm coming in with a user that doesn't have access to it, and we see the data encrypted. And I can do the same sort of thing. All the stuff I showed you before with ODBC, I can do with OData here. So it's a way to kind of get the benefits of both worlds with both hybrid data pipeline and the open access server for role-based access control. So I think that's what I wanted to demonstrate at this point. And Susan, I'm going to turn it over to you for questions.
Thanks, Dennis. We have a bunch of questions that came in. So Dennis, I'm going to jump right in. How do I know which open access sample to use as a starting point?
Yeah, so there's several of them. I guess the first thing to do would kind of decide which language you're most comfortable with, whether Java is, you're a Java shop and you have developers, or is C more likely, something like that. So that would be the start. And we have samples in both of those. And then the other thing would be whether you want to invoke the SQL engine or not. So for example, if you've got a database that maybe has non-standard SQL, you definitely wouldn't want our SQL parser to get control of it, because it would probably flag error as invalid SQL syntax, something that may be legitimate for the database. So in a case like that, you would want to use a sample that does not invoke the parser. And then depending on what you're doing, you may or may not need to parse the SQL yourselves. Sometimes the changes they need to make when they intercept it are fairly simple, where they can take the raw SQL and just kind of paste another filter at the end. But in some cases, they actually would want to have the SQL parse. It's just easier to deal with. So I would say that would be my answer.
Okay. What kind of setup is needed for open access to connect to a data source? Is it impersonating another user or role specific to the data source?
So I'm leveraging in that demo, I was using the Oracle driver, and I was logging in with a couple of different Oracle credentials, one of them Dennis, one of them Progress. And then the difference was I did different things in the open access code depending on the role associated with the user. But as far as Oracle was concerned, it was just coming in with the normal database credentials. I wasn't really necessarily impersonating something. You certainly could. You could kind of set up a proxy and do things like that. You have flexibility in that because you do get control. At connect time, you can pretty much do what you want on that. But in that case, there was no impersonation.
Okay, so this person asked 3 questions. So I'm going to ask them one at a time because I think that they're all related. And I think, Dennis, this might be for you. But how does the encryption and decryption happen between the client and the open access at the time?
So all of the stuff I showed in the interface provider code, that is all running on the open access server. So the actual open access, in this case, ODBC driver, there was no specific code to my use case here. Really, it's the same driver for everyone. But typically, I mean, it's just all going to happen on the open access server as far as that. So what happens is, as far as the database is concerned, it sees the SQL, doesn't know that potentially it's been modified by open access coming in. It gives the normal result set, and then open access going through that. There are kind of methods that I go through to set up the relational result set. Basically kind of binding the rows and throwing the column other way around, binding the columns, throwing the rows. But at that point, the database doesn't know that I am modifying the result set to kind of mask data. It's all done, after that call has been made.
Okay, can you choose what data to be encrypted at the open access SDK level before sending to a client? And also, can the field and data be encrypted from the client to the server, assuming nothing is encrypted at the database table or column level?
So the example I showed was select only, so I didn't really have the capabilities to do inserts or updates. You certainly could. And I know of people, I don't know people necessarily inserting data, but what I do know is people taking something where a user will say, basically say, show me this particular info from this table where this column is equal to this value, and they'll pass it in clear text. While in the database, since it's sensitive information, it is actually encrypted. What Open Access has to do in that case is intercept the SQL, take the clear text in the filter, in the where clause, and then encrypt it so it actually matches what's on the database itself. I definitely see people doing that. So that is where you would encrypt data before actually passing it in to the database itself. It would be the same sort of process if you had a sample that did full CRUD, full update support, and you were inserting maybe a mix of columns where some are clear text on the database and some are encrypted. In that case, you would intercept it before and encrypt what needs to be done and leave alone what is clear text.
Okay. Oh, wait a minute. How are the encryption and decryption keys handled, and are the keys changed periodically or not?
So yeah, that's a good question. So what I intended to do here was just kind of show what could be done. So my encryption is trivial stuff. Basically, I looked online and I'm just made some methods to do the masking. I did some methods for the format preserving encryption. And then the other one is AES encryption, I think. So you could either, find your own, or I also know people using third-party products to do this kind of thing where there's an API that they would call to do it. But this sample is not really intended to be something like that. This is really just showing you what you could do and where you would do it in the sample code. So I just kind of found some stuff on the internet to do it. You would likely have something, whether a third-party product or something more kind of vetted by your security team for the kind of stuff you're talking about.
Okay. Are there any guidelines for how long it might take to create a driver with Open Access?
Yeah, so that's kind of one of the things that depends. And people definitely sometimes will do like an MVP, like a minimally viable product to start with, where it's not everything they want to do, but just to get something out there. But some of the factors would be, is it select only? Is it full CRUD? And then the amount of processing you do. So the good thing is, for what I'm showing here, there are samples to start you, so you're not kind of starting from scratch. But that would be the kind of questions that you would ask. And then a lot of the effort probably would be in testing and kind of QAing it. It's probably fairly quick to get a prototype up and get data back and going with it. But to kind of do more with it, you would definitely want to run it through a bunch of tests. Typically, a lot of times starting from scratch, we were talking more like 2 months, 2-man months of work. But starting with a sample like this, I expect it would be less. So but again, yeah, your mileage may vary.
Okay, we have a couple more. I'm just actually going to put one more call out to the audience. If you guys have any questions, I have a couple more questions that I want to ask Dennis and Todd. But if you do have any more, please put them in the questions panel. What technical background does one need to have to use Open Access?
So you would want to be familiar with the programming language you choose. The interesting thing is, I'm not a Java developer, and I was able to do this. And typically the people who do this are way more proficient in a programming language than I am. So that would be the start. And it's also, you would need to know your backend. So in this case, I'm talking about a database. So you would want to be familiar with SQL, what you might want to do with the SQL, be familiar with what you want to do with the result set. Sometimes people do stuff where it's not actually a database behind it, where they're actually coding to an API. Some years ago, we used to see a lot of open access against REST sources, just because there's so many REST APIs. Since that time, we've built a product called Autonomous REST Connector, which is kind of like codeless configuration where sampling REST endpoints. So I don't see near as much, but if it's an API that you're hitting, you definitely want to be familiar with that. So familiar with the programming language, possibly a database, and then, or if it's an API, you would want to know the API itself that you're hitting.
Hey, Dennis, your field experience outside of open access, how are you feeling, the technical background for our drivers as a whole, or maybe hybrid data pipeline? The reason I ask this question is, with hybrid data pipeline, I'm in marketing, don't have a huge technical background, and I was able to get some good results out of it. Are you seeing the technical requirements being a little bit less on the other drivers as compared to open access?
Yeah,
from your field experience?
Would be a higher level of technical competency for sure. And then, like you said, hybrid data pipeline, sometimes in the initial setup, you would want somebody sort of familiar with, setting up software on Linux and load balancers, but that's a one-time thing. And once that's done, it's very easy for, people to use it. Similar, Autonomous REST Connector, you would need to sample the data, and there's some certainly knowledge of the REST API involved to do that. But again, once that process is done and you've got a model for the Autonomous REST Connector, it's more usable for others. So I guess this is similar, except it would be a little higher level of technical skills to get started. But once it's done, it'd be the same as everything else, whether it's HDP, hybrid data pipeline, or Autonomous REST Connector, or any of the commercial drivers at that point.
You make a good point. I definitely needed some help getting HTTP up and going, but once it was ready, as a business user, I was able to use it. So it was pretty good.
Yeah.
Yep.
I mean, the goal is certainly to make this stuff as user-friendly as possible and, put it in the hands of, more and more people. Since this is an SDK, it's definitely going to require a little more than a commercial out-of-the-box driver, or even, potentially hybrid data pipeline. But we minimize it, certainly.
All right, I got time for one more. What is the difference between open access and your other connectors, which I think you've alluded to?
Yeah.
There are different points here and there.
So we have a lot of, just commercial drivers, just, off the shelf, ready to go. All you do is put in your credentials and get going, whether that's user ID and password, or maybe it's OAuth 2 or something like that. But they're, ready to go. And then you've got like a next thing, something like Autonomous REST Connector, where we have a lot of models built for that, for a lot of different REST sources. And I think it's 50 plus at this point, but people have their own internal APIs that they want to use. And in that case, there's an effort to kind of build a model for it. This would definitely be similar. The difference is Autonomous REST Connector is sampling and configuration using a composer, a UI, user interface. This would be, more down, actually having to know a little bit about a programming language. The good thing is there is samples, and there are different points in the code where you would get control to do certain things, whether it's that connect time or whether it's the SQL itself. And my goal in this is to make it even easier, because, I've been seeing people doing this for some time now, probably a couple of years. And I was thinking, if there could be sort of a quick start where not necessarily what you would want to do, but to show you where you would do these things, whether it's masking of a result set, or whether it's adding a filter to a where clause or something like that. What I think I might try to do is maybe do a couple tutorials to this with the code that you can kind of download and get going. So, but, if you were looking to do this, you would get pre-sale support, from me and people on my team, and we would certainly help you through the process.
All right, one question came in, so let's ask that last one. If we use APIs, which are called after the user authenticates, and the APIs calls the stored procedure based on their access permissions, can I use open access just to mask or modify data results from the stored procedure only to mask or encrypt the results before sending to the client browser?
Yeah, so I think you're asking, could we do something similar with stored procedures? You certainly could. It would be a different sample to start with. The particular one I started with didn't support that. I think, and I would need to look it up, but I think you would be more in the mode where you bypass the SQL engine. We have samples for that. And I think that would support stored procedures. And you would have the ability to change the call itself to the stored procedure and also modify what comes back from it.
Okay, great. I don't see any more questions. So with that, we'll close the session and thank everybody for attending on behalf of the DataDirect team. We hope you have a great day.
Thank you all.
Thank
See
you.
everyone.
Bye.